Hi, this is the second part of our rocks revision at the start of theme 14. We've looked already at igneous rocks and we've looked at sedimentary rocks. What I want to do in today's lesson is look at metamorphic rocks, like the one on the image around me as I'm speaking to you from inside a garnet crystal, and also fossils. You may find it useful to have your theme 6 booklet and your theme 9 and 10 booklets handy as well. Okay, let's go. If we look at metamorphic rocks, there are 4 of them on page 4 of your theme 14 booklet. As with other uh, types of rock, we start by looking at the texture. And the most important feature of the texture of a metamorphic rock is whether it's foliated or non-foliated. Foliated means that there's an alignment of crystals within the metamorphic rock. So a result of pressure. Now that alignment could be cleavage, where the grains that existed within a rock are aligned, or it could be schistosity, where we have crystals of mica that have grown, that have become aligned. Where we have non-foliated rock, there hasn't been the pressure acting on the rock. So what we have there are crystals that get fused together. A bit like if you have a bag of Maltesers in your pocket and the chocolate softens up and we end up with one big sort of slightly squished Maltesery mass. That would be a non-foliated rock. Another way to describe that is a sugary texture, where it looks like the rock looks like a broken piece of sugar cube. There are some terms that we use to describe then the relative size of any crystals in the metamorphic rock. We could describe it as granoblastic, where all the crystals are about the same size. Or we could describe it as porphyroblastic, a bit like porphyritic, I suppose, where you have some larger crystals surrounded by finer crystals. We also need to consider composition. Now, the composition doesn't work in the same way as, say, in an igneous rock, or even a sedimentary one, because for a metamorphic rock, composition is often determined by the parent rock material. But there are some fairly distinctive minerals. Garnet is exclusively a metamorphic mineral. You don't find garnet in other types of rock. Mica as well. Now you can find mica in igneous rocks and also in sediments, but mica can be a common mineral formed during metamorphism, but it's not exclusive to metamorphism in the same way that garnet is. The rocks that we're dealing with then, those that form by regional metamorphism, we have slate, which is mudstone that's been compressed, so it becomes foliated, but will still look fairly similar to mudstone. We've got schist, which is where we have foliations of mica, so sheets of mica that have grown through the rock, or gneiss, which is where we get bands of different coloured minerals. So we get darker bands and light bands within the same rock. So there's clear foliation within it. All of those 3 rocks are going to show foliation. In contact metamorphism, where the main agent is heat, we don't see foliation. What we can find, though, are rocks like marble or metaquartzite that have this fused sugary texture. The difference between these is their composition. Marble is made of calcite. Metaquartzite, as the name suggests, is made of quartz. So, what I'd like you to do is use these labels to annotate the diagrams of rocks on page 4 and to name each of those rocks as well. Have a go at that now. Okay, as well as rocks, we need to be able to identify fossils. There are 6 fossil groups that you can be asked to identify. We've looked at these in theme 10 in particular, but also a little bit in theme 9 as well. There are these 6 fossil groups are ammonites, corals, graptolites, plants, trace fossils, and trilobites. Now, ammonites or cephalopods have a distinctive coiled shell. That coiled shell is subdivided into internal compartments as well. Okay. Corals uh, look similar to modern day corals. These are tubes of very robust calcite that have a very distinctive sort of radial structure, a bit like the spokes in a bike wheel, to make a very, very strong uh, structure for the very delicate coral animals to live on top of. Graptolites are quite enigmatic organisms. They're long extinct. They've been extinct for 250 million years. And these were colonial organisms that lived in little pockets on the side of sort of branching stems. They're animals that floated around in the sea, huge number, and sunk to the bottom of the deep ocean after death. Very distinctive organisms, look like almost like little saw blades, and are very useful for dating rocks as well. Plants, pretty obviously, are plants. Uh, Although plant fossils can be tricky in terms of whether you're looking at the root, a stem, a branch, a leaf, a seed. Okay, so they can be quite varied in form, even from within the same organism. A trace fossil is some record of an animal's activity. Burrows, footprints, feeding trails, even fossilized poop, okay, what we call coprolites. And finally then, very distinctive trilobites. Trilobites are arthropods. They've got segmented, flexible exoskeletons, split into 3 parts, hence the name trilobite. You really can't confuse a trilobite for anything else. Now, as well as identifying the fossil groups, I'd also like you to think about the environment in which they lived. In particular, whether they were marine, so lived in the sea, or whether they're terrestrial and lived on the land. Finally, as well, there's some descriptive terms we can add to that, particularly for marine organisms. Some of these animals would only live in warm water. Some will only live in shallow water. Others we only find in deep water sediments. Okay. So what I'd like you to do is, for the fossils shown in the diagrams on page 5, I'd like to identify the fossil groups, work out which environments they would have lived in, and see if there are any other descriptive terms you can add to that. For some of them, you won't be able to add any descriptive terms, but see what you can come up with. Okay then. As we watch the sunset, what I'd like you to do is make sure that you've identified and labelled up all of the diagrams of the igneous, sedimentary, metamorphic, and fossils that we need to be familiar with before we can get stuck in to start thinking about geological maps, which is for another lesson. I'll see you then.